Hello, math and physics students. This is Dr. John, your physics professor, here to help you with another physics problem. This one is about a ball being knocked off a pool table, something if you've played pool or snooker, you've done this quite often. And what happens is this pool table is 0.6 meters tall and the ball gets thrown straight off the table, straight horizontally this way. And we want to know two things about it. We want to know how long it takes to hit the ground, and we want to know how far it goes. So I'm just going to draw those in there. So we want to know the time, big question mark, and we want to know this distance. With these kinds of problems, they're called projectile problems. They are all very, very similar in nature. We'll tend to have an initial velocity, or we'll want to find the initial velocity, and often we'll have components. We'll have an initial velocity in this direction and in this direction. This is the straight up and down, this is the horizontal, this is the vertical. We may be given a velocity in this direction, but then we use Pythagoras' theorem to find the y velocity and the x velocity. In this case, we're fortunate. We're just given that the velocity is all initially just in the x direction, and so I'm going to write that down here. So the velocity in the x direction is 2.4. The velocity in the y direction is 0. It doesn't have anything going this way. What we do is we break these things into components, and then we use some of the principles that we have from our motion equations. Right here I've written out 4 of the basic ones. What I would do if I was doing this for an assignment, I would look at the question, try to figure out what there is, diagram things out, and then what I would do is I would write out the basic motion equations. You might have a cheat sheet. If you don't, look at my website, physicsdoctor.com. I've got those there for you. And I would look at the cheat sheet, and then I would come back to my board or come back to my paper and write out the equations without looking back at the sheet. This is going to greatly help you. If you do this every time, say you do this 10 times a day while you're doing your assignments, you're going to have a much better knowledge of these. You may not need to memorize them. However, you're going to know them so well so that when you come to a problem, immediately it's going to pop into your head, aha, this equation or this equation. What we're looking for is an equation that will help us to find something that we're looking for here. Well, here we have the fact that it's going this way initially, but we want to know how long it takes to hit the ground. Now, the only thing that's going to cause it to hit the ground is gravity. Otherwise, it would just keep on going this way if gravity was not in effect. This horizontal velocity continues on forever in the same velocity. This one here going down, though, is going to accelerate downward until it hits the ground. Only when it hits the ground will it stop moving horizontally. So what we need to do is find how long it takes to fall this distance from there to there, which is 0.6 meters. Is there an equation where we have the distance that something goes, we have the acceleration, which would be the acceleration of gravity. So the acceleration equals gravity going downward. Is there an equation that will give us the time that takes? Well, let's take a look at our equations now. This one won't help us. This one, we have the acceleration. We don't need the final velocity going down. This would help us with the final velocity going down. We don't need that, but take a look at this one here. Up and down, if we just look at the up and down part, just up and down, we're not looking at this way, just up and down, the initial velocity going down is 0. So this would be very, very useful. This would allow us to find the time that it takes to hit the ground. I'm going to rewrite this equation up here and erase some of the others. Here I've rewritten this equation up here. Remember, I'm talking just simply about the y direction, this direction up here, not this way. So because we know the distance going up and down. So since we know the distance going up and down, the initial velocity as it falls down is 0. So this is going to be 0. So all we're looking at is the distance is equal to 1/2 acceleration times time squared. We know what the acceleration is. That's g, going up and down. So the distance is equal to 1/2 g times time squared. Let's solve for time. We take the 2 to the side and divide by the g, and we're going to get t squared is equal to 2d over g. Multiplying by 2, dividing by g. Now I'll take this and I take the square root of both sides. Let me write this over here. So t is equal to square root of 2d over g. Of course, you could make a plus or minus here, but having a minus time doesn't make any physical sense. Often with your mathematical formulas, you're going to find answers as well that don't make physical sense. You toss those aside. The negative time actually would be if you have this go back again this way. So the negative time doesn't make any sense. We're just going to want the positive time, and let's plug in the values for here. So this is going to be the time is equal to the square root of 2 times distance. Distance is 0.6. 2, 0.6. Always use brackets, not x's for multiplication, over g 9.8. 0.34 seconds. So it takes 0.34 seconds for it to hit the ground, purely based upon its downward velocity, its downward motion due to gravity. I'm going to write this time in here, 0.34 seconds. Now we'd like to know how far it flies off the table. To do that, what we're going to use is the initial velocity, because the initial velocity in the x direction never changes, and it's going to continue to fly in the x direction as long as it doesn't hit the ground. So for that amount of time. So I'm going to take this here, 2.4, and multiply it by 0.34. This is about 1/3 of 3, so it's going to be about 1 or something like that. About 1. Let me check my calculator. I'll be right back. I am getting 0.816 meters. That's how far it would fly. In these problems, when you're finished it, I would always carry more than the significant figures. Here we have 2 significant figures, 2, and here I put this into 2 significant figures. I would always, in my calculations, carry more than 1 until you carry more significant figures than is given. Maybe 1 more. And then when you come up with a final answer, write it in the number of significant figures that your initial question is. So this would be 0.82. So the distance here is going to be equal to 0.82 meters. That's a basic projectile, a very simple projectile problem. I hope that helped you. If it did, like, subscribe, and check out my next video. Talk to you later. Bye-bye.